All right, so this is just to kind of make sure that we understand how to work with these absolute value functions and are able to do a few things with them. So with this first one, it asks us to find the vertex and to find the transformations. And so the vertex you're able to find just by taking these 2 points, and it's always the opposite of this number, the number inside. It's the opposite. I think of it like, oh, I'm trying to take this 3 and I'm trying to get it out. So whenever I try to move something in an equation, I always have to do like the opposite of whatever's happening to it. So if you had a -3, you'd have to add 3 to move it out. So the x coordinate of the vertex is +3. And then this one's already out, and so I'm just going to use it as a -1. So similar with this one, when you find the vertex, you're going to be using this number and this number. You're going to use the opposite sign of this one because you have to move it out, but this one is already out, so it's just the same sign as the number that you already see there. And then down here you have a +5, and then there's no number on the end, and so whenever I see a missing number somewhere, I like to put a +0 in its place, and so then we can see the vertex here as well. So I'm just going to use the opposite of that number, and then I'll use that number. Okay. Next, we're going to find the transformations. So I'm just going to write down the different transformations that you can see in the equation. So there's 3 transformations you can see from the front. There is, if it's reflected over x, if it's stretched, and if it's compressed. Vertical stretch, vertical compression. Okay? 3 things you can see. From the inside, you can see if the graph moved to the left or to the right. So and it's one or the other, so that's only one thing you can see. And then the number on the end tells you if the graph moved up or down. So again, that's only one thing you can see. So 3 things you can see from the front number, 1 thing you can see from this inside number, 1 thing you can see from this end number. So for the first number, if it's got a negative in the front, then that means it reflected over the x, which means that the V graph is upside down instead of right side up. That's what it means if it's reflected over x, and it means that there's a negative in the front. So that did not happen to this graph. This graph is a +2, so there's no negative in the front. That transformation did not happen. However, that did happen down here. You see a negative in the front, so that did reflect over x. And so if this problem had asked what the transformations were, you would say, oh, it's been reflected over the x-axis. The transformations are asked on this one, and there's a negative in the front, so you are going to write that. You're going to say, oh, it's reflected over the x-axis. For the next one, you look at the numbers that are in the front to see if it's stretched or compressed. So the stretch is if the number is bigger than 1. The compression is if the number is smaller than 1. So stretch if the number is bigger than 1, compression if the number is smaller than 1. And I'm not talking about if it's negative or positive. I'm just talking about the size of the number. Is the number bigger than 1 or smaller than 1? So this one has a number that is a 2. 2 is bigger than 1, so that's a vertical stretch. So for this particular problem, I'm going to say that the graph has a vertical stretch of 2. So that means that this graph is going to look tall and skinny. It's going to be twice as tall as a regular graph. This graph has a 1/2 in the front. I'm ignoring the fact that it's negative because I know that negative is not a compression. Negative just means that it's upside down. That's all negative means. So the 1/2, however, means that the graph is compressed. It means that someone took the graph and they said, you should not be this high, you should be half as high. So they took the graph and they squished it and they made it short and fat. So this graph is squished. On the next one, there's not a number in front. So the negative's in front, so it's been reflected over x, but there's no number in front, which means that this graph is just regular. It's not tall and skinny, it's not short and fat, it is just normal. Okay, so next we look at the absolute value signs and the number inside, and it's left and right, and it's kind of like the opposite of what you would think. So just like how this -3 actually becomes a +3, it kind of messes with your mind because you have to think of it as like the opposite. So a -3 seems like it would be moving to the left, but it's not. It's the opposite. It's actually moving to the right 3. Right 3. Okay. This next graph, if we were to write the transformations, this one would be moving to the left 4. This next graph down here, this one would be moving to the left 5. Okay. The next transformation is on the end. It talks about whether or not the graph is moving up or down, and this one is exactly what you would think. It makes sense, you know, you took the -1, you stuck it right there. It's not the opposite, it's exactly what it says. So this graph, oops, I was pointing to something you couldn't see. This graph is moving down 1. This graph is moving up 3. And this graph didn't move at all. So for up or down, you're just not going to say anything. So for this one, I'm going to say the graph moved down 1. So these are the 3 transformations for that first graph. And now that I have these answers, I'm going to go ahead and do what it asks, which is sketch the graph. And so I'm going to start typing in my equation. So the first thing you do to type it in is you hit the y equals button right here, y equals. And then we're going to go ahead and type the 2 first. And then to get the absolute value sign on the graph, we have to hit the math button. So I'm going to go over, here's the math button right here, the math button. And then we want that second column number. So I'm going to hit the right arrow to number, and then the first option says ABS. That's for absolute value. So in the first one, and I'm going to go to the bottom of my calculator and press enter. And what happens when you do that is the absolute value signs pop up on the screen, and so now I have to type x minus 3, and so the x is right here, so x minus 3. And then I want to get out of the absolute value sign, so I'm going to go right arrow to get out of it, and then minus 1. So now I have graphed the equation, and so now, or I have typed the equation, so now I can hit the graph button and graph the equation. So there's my graph right there. And so now I'm going to go ahead and look at the table. You can see that in blue right here. So I'm going to hit second graph to look at my table. And the point that I want to look for is the point 3, -1. That's the vertex. That's the very middle of my graph is 3, -1. So I'm going to graph that over 3 down 1, 3, -1. Okay. And now I'm going to plot 2 points to the left and 2 points to the right, and then that'll be enough for my graph. So over 2 up 1, over 1 up 3, over 2 up 1, over 1 up 3, over 4 up 1, over 5 up 3, over 4 up 1, over 5 up 3. And there's my graph. Okay. Now, if I had to find the domain and the range on this graph, which you do have to do in the other graphs, so we're going to look at it, the domain and the range are just looking at all the x values that I'm able to have and all the y values that I'm able to have. So the domain of this graph, I would look for the left side of the graph, and I would look at the right side of the graph. And what I notice on the left side of the graph is that I have an arrow that points to the left, and that means that the graph goes to the left forever. And the number that represents left forever is negative infinity. So I'd say, okay, this graph goes to the left forever. I have an arrow pointing to the right. That means that this graph goes to the right forever. And so if I was to say what the domain of this graph is from the left to the right, I would say the domain of this graph is negative infinity to positive infinity. And that's my answer. I wouldn't think of it any more deeply than that. The range is the y values. So with the range, we're going to think in terms of down and up. So I'm going to look at how far down my graph goes, and I'm going to look at how far up my graph goes. So my graph goes down to the vertex, and then it has arrows that mean that it goes up forever. So if it goes up forever, then that's an infinity. Up forever is an infinity. So down to the vertex means it goes down to -1. So the range is it goes down to -1 and it goes up to infinity. So down to -1. Now with the infinities, I always put parentheses there because I can't actually hit infinity. If you said, Miss Rice, show me on the graph where it actually touches infinity, I'd say, oh, it touches infinity right there. And you'd say, no, Miss Rice, that's 4. That's touching 4 right there. So even if I can touch an arrow with my finger, I can't actually say that it's hitting infinity because it's not. That's just a number. Now with the -1, if you say, Miss Rice, where's the y value equal to -1? I can show you it's right here. That I can actually touch with my finger. So anytime I can actually show you that it's happening there, that the thing that I'm describing is really true and it's there, that gets a bracket. So since -1 is something that I can actually see, it's right here, I can touch it, bracket goes with that number. Okay. Next, the other thing that the worksheet asks us to find is increasing and decreasing intervals for one of the problems. And so I want to do it on this problem so that we can just remember how to do it. So with increasing and decreasing intervals, I would just draw a little sketch. It doesn't even have to be very accurate. You could just graph it on your calculator and draw a little sketch from that. And so from there, I like to take a little stick figure and I say, which way is the stick figure walking? Is the stick figure walking uphill or downhill? So if you look at this, the stick figure would be walking downhill first. And so that means that the stick figure is decreasing. And then the stick figure would get to the vertex. And then the stick figure would turn around and start going uphill, would start increasing. So now what I have to do to write my answers for my increasing and decreasing intervals is I have to figure out what number to put for a left arrow, what number to put right here where he turned around, and what number to put for a right arrow. So I have a left arrow and a right arrow, and just a reminder, the increasing interval and the decreasing interval, those are both x values. So that's why I'm thinking in terms of left and right. So I've got a left arrow, that's a negative infinity. I have a right arrow, that's a positive infinity. And so I know that he started up here, and he walked down, and then he got to the vertex. And if I think about this, the x value of the vertex I have written down, it's a 3. And then he walked to the right forever. Okay, so the answer for increasing, the word increasing is in between the numbers 3 to infinity. So the answer there is 3 to infinity. The answer over here for decreasing is in between negative infinity to 3. Okay, now infinities always get parentheses. And then if you remember, the numbers, they only get brackets if that thing, the increasing, the decreasing, if that thing was actually happening at that number. So we have to look at the 3, we have to picture the stick figure standing there. When the stick figure was standing there, was the stick figure walking uphill? And the answer is no. When he's standing right here, was he actually walking uphill at the time? No, he was kind of in between, so I'm going to put a parenthesis. When the stick figure was standing here, was he actively walking downhill? No, he was kind of in between, so we put a parenthesis. Okay, so that's all you have to do, but now you have 2 more problems to do it on. Those are the different things I was asking you to find.